Hi everyone, James again. This is problem 5 from homework 7, and it's about an ion that's moving in a magnetic field and the fact that you can extract the mass of the ion from the measurements given. This problem has a nice little subtlety that you wouldn't bother with on a test. You just work quickly to get the answer. But I'm going to talk about it because uh, it's important to the physics. And actually, it would be important to a conceptual question on a test. But this is going to take a little bit longer than you would need to take on a test. Okay, so the ion is subject to the force due to a B field on a moving charged particle, which is QV cross B. And the magnitude of that is QVB, or absolute value of QVB sine theta, where theta is the angle between QV and B. Okay. Now, the velocity is not given in this problem. The amount that's given that's relevant to the velocity is the period, which is going to be 1/8 of this amount of time it takes to complete 8 revolutions. And the period, if you're going in a circle, is related to the velocity by the fact that the distance traveled is 2 pi r, which is the circumference, and the time that takes is the period, so the speed is 2 pi r over the period. There's a subtlety here, which is that the particle is not necessarily traveling in a circle. It could be spiraling around the B field lines. So if a charged particle starts out moving perpendicularly to the B field lines, it will go in a circle around the B field lines. If it starts with a component of velocity parallel to the B field, so that it has two components, one perpendicular to the B field, one parallel, then it will spiral around the B field lines rather than going in a circle. So it'll have a component of velocity that is parallel to the B field and perpendicular. And the portion perpendicular is what's related to the circumference and the period. Remember, the radius here is of the circle it's going in is this. It's just also going to the right. So in this case, the component of velocity, or the magnitude of the component of velocity perpendicular to the B field lines, is the circumference of the circle divided by the period. And the convenient thing is that it is the component of the velocity perpendicular to the B field lines that is the part that gives the force, because we can write the magnitude of the force is magnitude of Q times B times V sine theta. That is QB magnitude of V perpendicular. Because if I redraw this picture, here is QV and B, and here's the angle theta. So the component of QV parallel to B goes like QV cosine theta, where this is theta, and the component of QV perpendicular to B goes like QV sine theta, or QV cosine of 90 minus theta, which is QV sine theta. Okay, so in any case, V sine theta is V perpendicular. And that is your Lorentz force, the force on the charged particle moving in the B field. This force is going to be the centripetal force because it points towards the center of the circle. It's perpendicular to this velocity because the force is a cross product of velocity and something else. So the force is perpendicular to the velocity. It's perpendicular to the B field because the B field is the other thing. And so it is in the radial direction of the circle, whether the particle is going just in a circle around B field lines that are into and out of the page, or whether the particle is spiraling around the B field lines. In both cases, the force, which is perpendicular to both the velocity and the B field, points towards the center of the circle. And so it's what's providing the centripetal force. And so we take the B field force and we set it equal to the centripetal force, or magnitude of the centripetal force, which I'm going to write in the form m omega squared r. Remember, it's mv squared over r. I'm sorry, omega is v divided by r. And so we can write mv squared over r as m omega squared r. Yeah, because omega is v divided by r. So I want to solve for the mass, and so I divide through by omega squared r, and I get qb v perpendicular over omega squared r. V perpendicular is the 2 pi r over the period. Omega is 2 pi over the period. It's the angular velocity and times r. So my r's are going to cancel. Oh, and this is omega squared. R's are going to cancel. One factor of 2 pi over the period is going to cancel. So I get qb times period over 2 pi. And so I can plug in the charge. It's a singly charged ion, so the charge is the fundamental unit of charge, 1.6 times 10 to the negative 19 coulombs. B is given as 2 times 10 to the negative 2 Tesla. Period is the time that's given, which is 2 times 10 to the negative 3 seconds, divided by 8, because the given time corresponds to 8 revolutions. Period is the time for 1 revolution. And it's the period, which is the time divided by 8, period divided by 2 pi, so 2 pi. And I get that the answer is then 1.3 times 10 to the negative 25 kilograms. So we've taken the mass of an ion by measuring the time the ion takes to travel in a circular path in a known magnetic field. So I hope that was useful, and thank you for your time. Have a nice day.